Scratch is a programming language that is used on multiple platforms, tools, and softwares around the world. Here's a platform where we're using Scratch mixed with machine learning. In this example, we can say mean and nice things to the smiley face, and it will recognize which is which. Now I'm going to show you how we can provide many happy phrases and mean phrases, and the smiley face will respond with the correct emotion. So let's start off with something nice. You look great today. There you go, it's a happy face. Let's try another nice example. I like you very much. He's happy again. Now let's try a not so happy phrase. You are very mean to me. Aw, there you go. You can see how he's sad. So you can see through this example that Scratch is what's able to model a machine learning problem. Scratch is also used in one of the robotics platform, LEGO Mindstorm's EV3. Let's check it out. Here's a simple program which will maneuver the robot. Let's try it out. So let's look into this example program I built on Scratch. This program is a game where the ghost sprite will continuously chase the cat sprite. And this is done by seeing this ghost sprite's code. Let's look at the ghost sprite's code. So I said that when the flag is clicked, go to -103 for X and Y 27. That way it'll always start in that position and will never go to any other location. Then I said forever point towards cat. Cat is the name of the other sprite that I've defined, and move 10 steps. Then I said wait 0.1 seconds before it points again. So we can try this out. As you can see, the ghost started off where I told it to start, and it chases around the cat sprite. And I made the game so that when the cat is touched, it will say oh no, and after 2 seconds the game will stop. Hi guys, I'm looking at you guys directly from Cosmo's camera. Cosmo is a very unique and intelligent robot which uses artificial intelligence and robotics. And today we're going to write some very simple programs which will allow Cosmo to do some very cool functions. So the function that we're going to make Cosmo go through is we're going to make Cosmo move forward 100 millimeters once. So let's start the program. So when we get into the code, there's two main functionalities. A when condition and do. Now, as of right now, for this simple code, we don't need a when condition. We just want Cosmo to move forward. So we go into the do side and we press enter. And all of Cosmo's unique functionalities pop up and more. But let's go with move because we want it to move. Once we select move, it gives us the options and we select ahead. Then it gives you the options for how much we want Cosmo to travel. And we select 100 millimeters. And the last button is you select once, because we don't want Cosmo to move forward multiple times. So let's test it out. As you can see, Cosmo moved forward 100 millimeters once. Now that we've covered the do section of Cosmo's capabilities, let's look at the when section. So I've written a basic line of code where when see cube 1 in frame, then it goes to the do section and does that. So I wrote when Cosmo sees cube 1, and each cube is unique in its own way. As you can see here, cube 1 has this unique characteristic and drawing on it. So when Cosmo sees that cube in the frame, it will go and do the function that I told it to do. Let's test it out. As you can see here, Cosmo moved forward 100 millimeters when it saw cube 1. So now that we've covered the when functionality, the do functionality, let's head for subtasks. As you can see here, in this line and this line, both of these are subtasks. So in the first subtask, I said move toward it. It refers to the cube I mentioned earlier in the when statement. When see cube 1 in frame, move ahead 100 millimeters once, and then after that, move toward it. After that, I told it to grab the cube and it'll pick the cube up. So if the code works, the robot should look at the cube, drive 100 millimeters forward, look at the cube once again, drive towards it, and pick it up and put it down. Let's test it out. As you can see, Cosmo drove forward 100 millimeters, it looked at the cube, and it drove towards it. And then it picked it up right now. There we go. You can make Cosmo do all sorts of tricks. For example, I'm going to make Cosmo pounce on my finger. Let's make it happen. So if I move my finger in front of Cosmo, he's going to look around for anything that will move, and he's going to pounce on it. Ah, there we go. He pounced on it.
In this course, we are going to learn Python by doing a simple hands-on experiment. First, put a simple switch and then attach power to it. So let me push the button, on, off, on, off, on, off. We will attach pin number 6 to the positive terminal of the LED, and we are going to attach pin 7 to the ground terminal of the LED through the resistor. Let's say there is a need for this LED to turn on and off 10 times. This is how it goes. For I in range 10 means 10 times. The program is complete. Now let's save it and run it. Here we go, run. Look at the LED, on, off, on, off. So this is going to repeat 10 times.
So here's a really simple example of artificial intelligence. This smart classroom example has a fan and a light, and it'll turn on and off based on our textual command by learning through examples. In artificial intelligence systems, there's typically 3 phases: to train, to learn, and to test. Let's talk about the training first. Just as humans learn through examples, machines learn through examples as well. Let's get into the training of our example. So in our smart classroom example, let's focus on the fan. The fan has 2 main functions, to turn on and to turn off. In AI terms, these are called labels or buckets, so let's add them now. The first label we'll add is fan on, and the second label is fan off. Now let's add some examples. The system will use these examples to train itself. So our first one will be turn the fan on, and another one will be switch the fan on. Now that we've finished typing our labels and their examples, let's run the training. This will take about a minute. Now that we've finished training our model, let's try some examples that the system hasn't seen before. So we will enter, can you please turn the fan off, and test. So as you can see, the system recognized it as fan off with a 96% confidence level that its answer is correct. Now let's try building this same model in Scratch. Alexa, open STEM coronavirus.
Welcome to Corona Cases.
Alexa, how many coronavirus cases in the U.S.?
2,957,251.
Let's move on to making our custom skill. To do this, we press Create Skill, and our skill name will be coronavirus, and the language will be English. Our model will be custom, and the method we will choose is Alexa hosted Python. Then we scroll up and create skill. Okay, our skill has been created. Now let's move on to invocation. Invocation is a phrase you use to launch your skill. We're going to name ours STEM coronavirus. To test our invocation, let's move on to the code tab. So here on line 8, we have launch request. And on line 11, this is the speak output on what Alexa is going to say. She's going to say, "Welcome to my first Alexa skill." Let's save and deploy. In order for this skill to work, we need to get some corona stats. So we found this website that has a lot of good data on coronavirus, so let's go to it. And paste. So as you can see here, they have all the data about coronavirus, but today we'll only be using corona cases and corona deaths. So let's go back to the code and paste the code that helps us get the data. Now that we finished writing the code, let's test it out. There are two methods of testing. One is the Amazon Echo, and the other one is the Alexa simulator on the developer console. So let's test out the simulator first. So we're going to type whatever we would have set to Alexa if we were using it on the Echo. So we're going to say open stem coronavirus. And as you can see, she says, "Welcome to corona cases." So then we'll ask her, how many corona cases in the US? And she says the number. Now let's move over to the Amazon Echo. How many corona cases in the US?
2,972,224.
It works!
So here we have a model traffic signal, which is meant to simulate a real traffic light. As you can see here, we have the car light, which is meant to allow the cars to go and stop. Across from that, we have the pedestrian light, which allows pedestrians to know whether they can cross the street or not. And across from the pedestrian light, we have the pedestrian button, which the pedestrians can use to change the light. So now, let's start building the code. Now that we've written the code, which will allow the traffic signal to function, let's try it out. So as you can see here, the light is red, the traffic light for the car is functioning perfectly, and the pedestrian light stays red. Now that we've finished writing the code, which will interrupt the regular traffic pattern, let's understand it. So as you can see here in line number 42, we used the GPIO's built-in function called addEventDetect. And this function has 4 inputs. In the first input, it requires the GPIO number, which we defined earlier with the variable pedestrian button. In myInterrupt, this is a function that we defined which interrupts the normal traffic pattern and introduces the pedestrian traffic flow. When I press the button, the pedestrian light turns to green and the car light slowly goes to red. Now it goes back to its normal pattern after some time.
Here we have Raspberry Pi with camera. Let's take a picture using Python code. Come on over. So we push the run button. Look at the camera. Wow, it recognized our faces and eyes and even counted them. As you can see there, it shows 3 faces, 6 eyes. Computer vision is used in self-driving cars, facial recognition, and many other areas of life. We have built a simple system to play with this technology. In this lesson, we will be writing Python program to detect human faces using OpenCV and Raspberry Pi. And finally, we call the function show image and pass the image object. So now the program is complete. So let's run it. Look at the camera. Here you go.